Hi everyone, I am Milan, and I know that I have been quite silent here on YouTube for a while, but as you might have seen on my other channels, I was pretty busy with publishing books these days. So, on the one hand, I can highly recommend to check out those books, and on the other hand, I promise I'm going to be back with lots of new tutorials on YouTube next year. And speaking of new tutorials, I thought that I will put together a very quick, brief one using Gephi and network visualizations. So, this one is about the TV show called Arcane. You might have heard about it in the past few weeks. It has been quite a hit on Netflix, and it is based on a computer game called League of Legends. I'm not really a gamer myself, but even I have heard about it. It's pretty famous in gaming circles, as far as I know. And and also the TV show on Netflix was really cool, amazing visuals, exciting storyline if you like fantasy and steampunk stuff. And as I usually do when I see a cool series or read a nice book, is that I start to turn it into data. And in a few days, I'm going to publish the tutorial, the Python tutorial behind this network, which is going to show you how I created the network, how I collected the data about Arcane, and how I use Python to build the network. While here in this tutorial, I'm going to show you how to visualize the network using Gephi. So here I already have Gephi on my screen, so I just load the Arcane Network graph file. As you can see here, we have about 15 nodes and nearly 200 connections between the Arcane characters, which, as we will see very shortly, are placed in a random layout on Gephi when we open the network first. So after reading the graph, here we are with the initial random layout, meaning that each node is positioned on the canvas at random. So the first thing I usually do is to select the layout, and I usually go for the Force Atlas layout. If we just run the layout with the default settings, we are going to have a very packed network, so I usually start increasing the scale of the network. And I usually add some gravity as well, which will organize them in a more circular structure, meaning that they are all the nodes are attracted towards the gravity of the center of gravity of the network. But they also get closer to each other, so usually keep increasing the scaling factor. But now at first it looks alright. So the next step I usually do is to change the node size, where I will simply scale the node size based on the number of connections they have, so based on the degree, and let's say I will scale it between the 5 and 55 range. Once applying this scaling or node sizing, we see that the most center ones are a little bit large, so I just keep increasing the scaling factor. And we are arriving at a kind of nice structure here, but we are still missing an important point, which is the coloring. So what I usually do is that I compute the communities of the network, which we can do here in the statistics tab under the modularity command. And now just go for the default resolution, which will result in 4 different communities. And then we can go to the coloring in the appearance nodes tab, here this color palette, pick partitioning and modularity class, where we can color each node based on its modularity class or its module index. So this is how it looks like. We can also turn the background dark, which might look a bit better, but we will get to that later. Now let me also start to tweak the layout a little further, maybe further increase the gravity, maybe increasing the scale a little bit as well, and even further increase the gravity. We can try to use this function called disute hubs, which will also start to align them in a more circular pattern. And then I can add the labels. Usually this is the step where I switch on the node labels. Here you can see all the labels with the same font size. I usually prefer to use a node size label size instead of this. So the label sizes are proportional to the size of the node itself, so the degree of each character as a node in the network. So the larger a node, the more central a character, the larger the label. Okay, so I think that this is kind of alright for the labels, at least for now. And now a bit detour on the coloring. You will see this in the Python tutorial as well, but what I will do is that first I export the node table. Here you can just use the export table function. I will export it into a nodes.csv spreadsheet, and then I will process it in Python. And my Python script will result in another spreadsheet which will contain the colors of each node. So here first I assign a color to each community, that is 4 colors, and then I will use this to map a color, the corresponding node color, to every character one by one, and then store it in another spreadsheet which I will call here Arcane Colors. Here you can see that it has 2 columns, the node ID and the color with its hex code, which we can quickly incorporate into this visualization and append it to the existing workspace. And once it's included, we can use this additional mod or plugin of Gephi and just color each node based on their color attribute, which you can also double check in the data lab. Here, nodes, ID label, and here there is a color column which we just included from the additional spreadsheet. So one more thing here, we can see that there are a few node labels which are kind of overlapping, so we can do a label adjustment, which will just move the nodes around a little bit so that they don't overlap. And now let's go to the preview and start to create the final print-ready visualization. So here in preview, we usually start from scratch, but it's alright. First I pick a dark, not completely, but nearly black background, and I switch off the border width, and I usually apply a mild transparency on the nodes. It just gives it a nice, like shimmering look. I will also add the labels, maybe decrease the font size. I will even further decrease the font size. And also change the font color, maybe white or almost white. Yes, and this will probably be good. Okay, so what else do we have here? We can also fine-tune the lengths. I will introduce an opacity of 70% and increase the edge width a little bit. This way the stronger connections will be more visible. Maybe I will also apply a scaling so I can actually change the upper and lower bounds of the edge width distribution. This will kind of highlight the stronger connections and makes the weak connections less pronounced. Yep. Now we are making some progress. I will increase the thickness and tune this down and tune this up. Okay, maybe this is a little too much. So this is kind of changing the contrast between between the low and the high weight connections. Yeah, maybe this is fine. Yeah, I kind of like this. And now we can see that we are almost at the final stage of the network. Here you can also see that these colors correspond to the different kind of storylines or groups of people within the network, which actually makes sense because a network community is usually a group of nodes which are much more connected to each other than to the rest of the network. So that is why we have this cluster of the center family, Jinx and Vibe and Vendor, for example, in pink, or the leadership of Piltover in kind of gold, while by neon green we can see the enforcers, so the military parts of Piltover, while the gangsters and the people who kind of were running this part of this realm called Zone, they are here marked by blue. So this is how the network looks like, and at the end we can also use this button to export it in PDF or PNG or any other format that you would like to use. So, but I will leave you to that, to explore that for yourself, and I will show it in a new video, sometimes probably early next year. So, long story short, this is how we can use Gephi to visualize and customize a network graph, showing, in this case, the characters and the interactions between the characters of the popular show Arcane. Thank you for watching and have a great day. Bye.